Hello, grade 10s. I hope you all remember that we are starting with physics today. So we are in your books on page 123 and we're starting with electrostatics. Okay, so you did some of electrostatics in grade 8 and in grade 9. So the important things that you have to know is that obviously like charges repel one another en ongelyksoortige ladings trek mekaar aan. So plus en plus stoot mekaar af, terwyl plus en minus trek mekaar natuurlik aan. Okay, then you also need to know that when you have forces between charged objects, those are known as electrostatic forces, and the unit for those forces is coulomb, and we write it with a capital letter C, but please do not confuse that with the symbol. When we are talking about charges, the symbol is Q and the unit is C. Okay, dan 1 elektron se lading is verskriklik klein. Dis minus 1,6 maal 10 tot die mag min 19 coulomb. So 1 coulomb het in totaal 6,25 maal 10 tot die mag 18 elektrone. Graad 10s, ek verwag nie van jou om daai goed te weet nie. Die elektron se lading is 'n konstante. So if we want you to use that, it will be given to you on the formula page. So you don't need to know that, but that is just to give you an idea of when we are talking about an electron, how small a charge that truly is. Okay, nou kom ons by die ontstaan van 'n lading. So ladings het verskillende maniere hoe dit kan ontstaan. Wrywing, aanraking en induksie. I'm only going to speak about some of those today and then give you homework, and then next week we'll carry on the rest of them. Okay, so as ons praat van wrywing, friction, if you have a piece of glass and a piece of wool and you rub them against one another, there is a transfer of electrons. Now remember, when something gains electrons, it becomes negatively charged. So in this case, this piece of cloth has more electrons than protons. So this cloth will be negatively charged, while this piece of glass rod has lost electrons. So a loss of electrons means it becomes positively charged. 'n Ander manier om 'n voorwerp te laai is wanneer jy 'n voorwerp met 'n lading aan 'n ander voorwerp laat draag. And what you guys need to know is that the charges will then be distributed equally between the two objects. So hierdie ene is negatief 3,6 nanocoulomb, and then we have a transfer of charges to this one. So in the end, you will see that they have equal charges on both of the objects. So al wat ons hier gedoen het, en ek gaan dit nou vir julle wys op die slide ook, is ons het net die ladings bymekaar getel. Hierdie een is minus 3,6, hierdie een het 'n nul lading. You add them together and you divide it by 2 to find the final charge of both of the objects. Goed, hierdie ene sien ek het hy nou hier fout gemaak. So hulle vra vir jou, as jy 'n lading het met positief 4,8 microcoulomb, ons sal nog praat oor die micro en die nano, jy hoef daaroor te worry nie, en een het wat negatief 2,4 microcoulomb het, dan is daar ook a transfer of electrons, and then if you want to calculate what the charge on the final orbs will be, you just add those two together. So we have positive 4,8 plus negative 2,4, and we divide it by 2, want dit verdeel gelyk op tussen die twee. And then you get an answer of positive 1,2, and you just keep your unit the same as it was in the beginning. So this one will have positive 1,2 and positive 1,2. Okay. En hulle gaan aan, oei, hierso is hy's net 'n bietjie stadig. Goed, so al wat hulle vir jou hierso wys is as jy twee identiese sfere het en hulle raak aan mekaar, dan tel ons net die twee ladings bymekaar en ons deel dit deur 2. So jy bepaal basies 'n gemiddelde lading en dit sal dan elkeen van die voorwerpe se lading na die tyd wees. Okay, guys, your homework is exercise 10 on page 130, number 1, 5, and 8, and you will see those are similar calculations to the ones I just showed you. Okay, so julle kan daarmee begin, 1, 5 en 8, en dan wil ek net vinnig vir julle 'n video wys. Waar is my video nou een? Ek sal maar die video vir julle ook oplaai. Alright julle.